gravitational equilibrium. But then equilibrium is again of three types: stable equilibrium, unstable equilibrium, and neutral equilibrium. Now, from your 11th class knowledge, you already know that a system is said to be in a stable equilibrium and if the potential energy of the system is minimum, right? It is said to be in neutral equilibrium if potential energy is constant. And if the potential energy of a system is maximum in equilibrium, then we say that it is in unstable equilibrium. This you studied in that work energy power chapter 11th class equilibrium. Do you remember?
Mm. Okay.
So these things are exactly same here also. Now you can try this question. Just do it quickly. Draw the diagram. Diagram is must. Do it quickly, fast. You are doing very slowly. You have to increase your speed. Also, you understand that if you displace a particle from its equilibrium position, little bit, slightly, and then it again returns back to its equilibrium position, then we say that the particle is in stable equilibrium. If it is just the opposite, like you displace the particle from equilibrium position and particle moves away from the equilibrium position, then we say that it is unstable equilibrium. So just quickly draw diagram and see what you will comment about these particle. A test charge Q naught is placed at the point O. O has coordinates 0, 0. Now in this situation, what you think? The charge Q naught is in a stable equilibrium for displacement along x-axis. Means if you give a small displacement along x-axis, then does it return back to its equilibrium position or not? That you have to check. Draw diagram, do it fast. Any doubt you ask quickly.
Even if it's slightly displaced and come back to its initial position, the body is in equilibrium only. Equilibrium only.
No, not clearly audible. So again,
If,
little
if the
louder.
body, if the body slightly moved and come back to its initial position, then also the body is in equilibrium only. Sir.
Not equilibrium. Means equilibrium, it is already there. That the question, it is already in equilibrium. Now we are talking about whether the equilibrium is stable or unstable. We are not talking about equilibrium because it is already in equilibrium. If a particle is already, so whether it is in equilibrium or not, that is not the question. If that is the question, suppose that whether it is equilibrium or not, so that is only decided by net force. If net force 0 means equilibrium. Now we are talking about stable equilibrium and unstable equilibrium. So if you displace the particle from equilibrium position, means already it is in equilibrium. And from that position, if you displace it slightly and it returns back to the same position, then we say it is in a stable equilibrium. Are you getting it?
Yes, sir, I'm getting.
Again, you can ask your doubt. If you still have doubt, you again ask. Keep asking.
On our phone, it's the
So first one is correct or not correct. Diagram is must. What you are getting first, stable or not stable?
Stable equilibrium, sir.
Sorry, stable equilibrium or not stable equilibrium?
It's a stable equilibrium.
First. How can you say it is a stable equilibrium?
Unstable equilibrium.
You are saying unstable?
Unstable, sir, because
Okay. Because
sir, test charge may contain a small or a small unit charge, sir.
test charge is very a small amount of charge. Q not. Yes.
Sir, positive or negative charge, sir.
Positive. Very a small positive charge. So you are saying unstable. Why unstable?
Charges placed between them. Positive charges. So because when a charge is placed, there will be attraction and repulsion due to which the particles cannot go to initial position, we can say. No. That's why we can say unstable.
But the forces will help it return back to its initial position, so it should be stable. Why it is unstable? You have not drawn the diagram correctly then. Tell your answer precisely. Explain how you are saying it is unstable. Explain it.
Sir, because when we place, there will be attraction and repulsion, no, sir. Due
Why
to that,
there will be attraction? There will be no attraction first of all. Why attraction you are saying?
sir, because positive, negative attraction,
There
like
is there is no negative. Where is negative?
okay, positive. Oh, sorry, sorry. Repulsion between them will be no.
Yeah.
So it will be stable, sir, because even if we remove the charge, then automatically they will get into the same distance, no, sir.
So what is your final answer?
Sir, it's in a stable equilibrium.
Okay, go for second part. Correct. Go for second part.
Unstable for displacement along project equilibrium and unstable along.
If you displace it slightly along the y-axis, slightly, will it return back?
No, sir.
So unstable.
Unstable.
Okay, now you ask your doubt.
Sir, no, I like
No doubt.
no, no.
Okay. So now try this question. Do it quickly. Quickly write down the equation. Increase your speed. Do it little fast. And you can ask your doubt. Any doubt you have, you keep asking. You can ask your doubt, Himanish.
So here,
Okay, then do it quickly, fast, if you have no doubt. Why it is taking time?
so they're not in a stable equilibrium, no, sir.
They are not in stable equilibrium. Just give the logic. Why? Why you think?
Sir, either if you increase or decrease the distance between them, sir,
Hmm.
there will be no effect on the equilibrium conditions, you can say, no, sir.
Why there will be no effect, you think? Because
So, sir, initial condition, we can say gravitational attraction is G m1 m2 by r square, no, sir. If this
uh,
balance k q1 q2 by r square, then r square gets cancelled, so distance
means you
increases.
are means what you should say is that net force will remain zero
Yes, sir, net movement zero, we can say.
at all the separation.
At all, yes, sir, at all separations, net force remains zero, sir, because he mentioned at every point gravitational force is equated by gravitational attraction by the electrostatic repulsion, no, sir.
Yeah, so they will be in equilibrium at any separation. Okay, so if it is not stable, then which type of equilibrium? It is equilibrium or not equilibrium?
So it's a neutral equilibrium, can we say, sir?
Okay, so you are correct, right? It is neutral equilibrium because whenever you send them, okay, they will be in equilibrium, okay, and uh, you understand that the if we find its energy, uh, potential energy, then it will be gravitational potential energy plus electrostatic potential energy. That will also remain same because it both are function of distance, right?
Yes, sir.
That will also remain same because k q1 q2 is equal to g m1 m2. That's why. Are you getting?
I'm getting, sir.
So it satisfies the conditions of neutral equilibrium. Correct. Good one. Okay. So if you want, you can try this now. I think here it should be distance 2L apart. I think E is some misprint, I think. Check it. I think so. E should not come here. So if you have to prove that motion of a particle will be SHM, what you will do? What is the fundamentals of SHM? What we do?
So we need to prove acceleration at minus omega square, you can say.
Okay, so just think whether it is correct here or not. Draw diagram, read it, and quickly just write the equation. See, equation is coming satisfying SHM or not. If you have any doubt, you ask. Yeah, you have any doubt? Are you getting it? Are you doing it?
Sir, I'm doing, sir, just
Okay, okay.
yes.
अच्छे से काम तो भी काम आज पूछे See here, you should focus on a very important information which is given in the question, and that information is this word. See this one. Okay, this is very very important. Without this, you will not get the equation. Are you getting?
it is in simple harmonic motion only, motion we get.
Sorry.
It is in simple harmonic motion only, sir.
Okay. So process what you did.
Sir, first of all, no, sir. Sir, I found Fnet, sir.
Okay.
Uh, sir, Fnet I get k a square into 4lx by l square minus x square, sir.
No, so the first you displaced, right?
It's the first displaced by distance, sir, L.
Okay, and then you found the net force. Net force
Yes, sir.
final, what you are getting after simplifying, finally.
Sir, we get k a square by l square m into x, sir, which is kind of written as a
So
equal to
you
omega
use
square
here
x, sir.
some binomial expansion also?
Yes, sir. Well, since x is very small now, sir, here we can take
Yes.
by using approximation I've done.
Correct. This is what you did, right?
Yes, sir. And we got omega t equals to 2 pi by omega we can do now.
Yeah. This is what you did, right?
Yes, sir. Yes, sir. Yes.
Good one. Okay, and then you said time period 2 pi,
By omega we can say now,
omega, and what is omega?
sir. So by comparing this equation, it is 4k a square by l square l cube we
Correct,
get it.
correct, correct. Okay. So like this, right?
Yes, sir.
Yeah, so this is the general process, what we generally do. Okay, so now try this one. You can, if you feel that it is, you can do it, then simply you just write the equation directly, or you can explain the process what you do. You can simply express the process or just tell me the equation, that's it, how you will do it.
Net force acting on the particle should be zero now, sir.
Net
Sir,
force.
why net force acting on the particle should be zero, sir? Because the
Hmm.
system is in rest means.
Hmm. Yeah, so net force zero, and how many forces? Gravitational force and electrostatic, right?
Yes, sir.
More charges will exert the force, right? Force
Yes,
will
sir.
be in this direction. So after
And
that, what you will do,
in this direction,
right? Like
horizontal
this.
component. Yes, sir.
So what you will do after that? Vertical component, not
Yes, sir.
horizontal.
Horizontal will be zero, yes, sir.
Vertical you will take and equate it to vertical component of net force will be zero, right? Equate it to
Yes, sir.
mg electricity. Okay. Try this question. Are you getting it? Again, you have to do the same thing. Displace little bit and see the equation of the force. Is it directly proportional to
The
x?
acceleration is
That's it. That is what you have to do. And it will be, I think, it should be that proportional to z. Again, you will take here, you can take the approximation because it is given z is very, very less than a. So then that you have to see this. Understood?
it's understood.
See 4f cos theta, vertical components you will take, right?
Yes, sir.
Hmm. But I think they forgot to write the mg. Mg will be there, no?
Yes, sir. MU will be.
Mass they have not given. Okay, they have written neglect gravity. See this. Okay, so then you will not consider anything. And anyway, that yeah, so no need to consider that. You have any doubt, you can ask.
So no doubts.
Okay, so leaving this type of question, how many these type of questions are there? All related to SHM and all. So I'm leaving there. Now, electric field, what is electric field? Electric field is simply a region around a charge in which if any other charge will enter, it will experience a force. Now, a quantity is electric field intensity. So, at any point in an electric field, if you want to find what is the intensity of electric field, so at that point, you will place a very small positive test charge, you know, and then you will see what is the force acting on the test charge, and then you find the force acting per unit charge. So electric field intensity is at a particular point in an electric field is simply defined as the net electric force per unit charge at that point. So you measure the force acting on the test charge and then divide it by the magnitude of test charge so that you will get the force per unit charge, which is nothing but the electric field intensity at that particular point. In this, you have any doubt?
So no doubts, sir.
We already, I think, discussed about this. Now, there are some of the properties of electric field intensity. So, as you already know, it is a vector quantity. Direction of electric field intensity is always in the direction of the force experienced by a positive test charge. In this way, you can say that its direction will be away from a positive source charge and towards a negative source charge. Source charge, I'm saying. Its SI unit will be unit of force divided by unit of charge, so Newton per Coulomb. Dimensional formula, dimension of force divided by dimension of charge. If E equal to F by Q, then F equal to Q into E. Okay. All these things you already know. Now, It also, just like electric force, so if electric force obeys superposition principle, electric field will also obey superposition principle. Electric field is nothing but the electric force that is experienced by a unit positive charge. So if electric force obeys superposition principle, electric field will also obey superposition principle. Means if there are a number of charges and at a particular point you have to find electric field due to all the charges, then simply you can add their individual electric fields. Vector addition. Electric field is produced by a source charge. It does not depend on the magnitude of, or it is not produced by the test charge. Okay. So now this is the question. This is very, very good question. So think very carefully. If you have understood the definition of electric field intensity, then you can solve this question easily. Try this. Question is visible?
Yes, sir. Question is visible, sir. Now.
Okay. You have any doubt, you can ask. Tell me, Himanish, are you getting?
So 1 minute I'm trying, sir.
Okay,
It's
okay.
getting.
Why it cannot be, cannot see. Okay, so
Sir, E can be greater than F by Q naught. So we can say.
E can be greater than F by Q naught.
Yes, sir.
Why you say that it will be greater?
Sir, because I've considered and charged particles, sir, I got force of, so the force of attraction will be k q naught by r dash square, no, sir, if it is assume the distance is r dash.
Correct.
From that, f by q naught will be kq by r1 square or dash r dash square, sir.
Hmm.
We know that electric field is kq by r square, we can write, no, sir, because force by unit charge.
Hmm. Right.
From here, r dash is greater than r, so we can get, no, sir, from that f by q naught is less than e, e greater than f by q naught.
So, what is the final answer? E will be means E and F by Q naught. So E will be less than F by Q naught, you are saying?
Sir, E will be greater than f by q naught. Yes, sir, greater than.
E will be greater than F by Q naught. Correct. I also think that should be the answer. You know, that should be the answer because F by Q naught will give you lesser value, no? Because the particle, you know, it will move away because of the repulsion. Are you getting?
Yes, sir.
And so the separation will change. So if you will calculate F by Q naught, you will not get the F by Q naught. Okay, tell me one thing. So actual electric field will be F by Q naught, right? But that is not the electric field of this situation as shown in the diagram. Because the situation will change, no? Because of repulsion, it will move. It will get deviated at some angle, right? It will go at some angle here. And so the separation will increase. And because of increased separation, F by Q naught will have less value because F will decrease. Are you getting? So the actual value that we wanted to measure, that cannot be measured in this case. What will be measured is the F by Q naught, but it will be different from the actual electric field that should be there when it was in this position. Because of the repulsion, it will automatically move in this situation. Are you getting? Have you understood the question or not? You have the okay. You have doubt, then still you can ask previous question. If you have no doubt, then you can go for this question. You can ask if you have any doubt. You can also directly tell the process if you know the
That
process. That,
that
yeah.
here